Okay, so let's get started. We're going to be taking a look at working with our closed loop Lambda control once again for our Link G5 and G4X systems. Now, this tutorial, we're going to be focusing on setting up a wideband type of control. So it's going to allow us to do the closed loop feedback at idle, part throttle, wide open throttle. The last tutorial, we reviewed our narrow band type of control, really focusing on dialing in the closed loop for idle and part throttle where we command 1.0 lambda. A narrow band sensor isn't accurate outside of that very narrow stoichiometric scale of 1.0 lambda. When we have a wideband, we can read a full scale and allow the closed loop to work at all operation points of the engine. Let's jump in here and take a look at first setting up our wideband, making sure that's configured correctly. Then we're going to jump into our closed loop fuel window and start to go through all the settings, what they mean, and how to configure them. We can keep things really simple with the closed loop control or get more complex and advanced, really up to you how you want to integrate this. Let's jump in right now and we're going to move from our basics window to our analog inputs. Now, here's where we're going to assign and set up our actual wideband control, or at least the wideband type, I should say, that we're working with. So whether it's going to be an internal wideband, a Link G4X Fury has an internal wideband, a single wideband. If we have, let's say, a G5 Voodoo Pro that has dual internal widebands, we can set that in our Lambda sensor control source, so we can use the internal option. Link CAN is going to be if you're broadcasting your Lambda reading into the Link through a CAN module. It could be the Link CAN, it could be AM-X series. We can set that up. We talked about how to do that. The other option we have is an analog input from a wideband controller. So in this case, I have an AM-X series wideband control set up here. I have wire analog 3 as the 0 to 5 volt output from my AM-X series gauge to my Voodoo Pro. So this is just not my necessarily preferred method to have a wideband lambda reading, but it's just easy for this demonstration rather than wiring up the internal wideband. I just didn't get a chance to do that yet, but that would be my preferred option, is using the internal and actually wiring up an LSU, Bosch LSU 4.9 sensor right to the Voodoo Pro and taking advantage of that internal circuit. For right now, let's go ahead and just grab our analog volt 3 here just for this demonstration for the tutorial. The next thing we have to do is go to the calibration and set our calibration scale. Right now it's set to AM-X series UEGO, simple as that, don't need to do anything further there. The run when stalled is set to no. We leave it at no when we're doing an analog 0 to 5 volt option here for the wideband. What this will do if you have the internal option or the Link CAN Lambda, it will allow, if you set this to yes, it'll allow the wideband heater circuit to keep heating up the sensor and keep that circuit running. This may or may not be something that you want to do. If you're worried about draining your battery very quickly, you probably want to set this to run when stalled and set this to no, so that it doesn't have that heater circuit and enabled and starting to run. And then we also have our error low and high. This is going to be, if it goes below the volt or above this volt, it'll show that it has some type of an open circuit or a high voltage type of circuit situation. This can be a concern because if you're relying on your Lambda sensor for closed loop control and fail-safe strategy or protection, you want to know when there's a fault. In my case, the AM-X series wideband has a scale of 0.5 volt to 4.5 volt. So in this case, we've set our error low and high, 0.4 volt for the low, because 0.5 is the minimum output from the gauge, and then 4.5 is the high, so we'll set this to 4.6, just so we have a range that it can look in. Okay, that's set up, that's good. And let's move on to the next step. That's going in here to closed loop fuel, and we're gonna now go to our closed loop Lambda and go to Lambda mode, and we're gonna go ahead and select our auto mode wideband option. There are two other options here for the Stoich mode, so narrowband, wideband. We've talked about what the Stoich mode represents in the last tutorial pretty heavily, specifically for the narrowband option. If I'm running a wideband, there's absolutely no reason to choose Stoich mode wideband. You always want to choose auto mode wideband because it gives us a larger range of actual control and adjustment for the closed loop. Rather than being stuck to running 1.0 lambda target for idle and part throttle, we can rely on this for doing full throttle and keeping our fueling consistent and correct at our desired target coming from our target table when we're at full throttle. So we're always going to choose auto mode wideband when we're setting this up for working with a wideband lambda sensor. So we want to choose this option right here. Now, when we turn this on, we have a lot of things to discuss that we can change and control in here. Let's first just start running down the list of things that we can adjust. Now, the number of banks, this is going to tell the Link how many banks of control it's dealing with, specifically looking at the wideband reading. So if we have 2 lambda sensors, one in each bank, you'll have to go and choose the option of 2 here. Now the next option, bank one source, this is Lambda average. That's typically when you leave it on the default setting. You could set it on Lambda 1. What this is going to do if you have it on Lambda average, the closed loop control will work on if you have multiple wideband sensors. Let's say you have a 4-cylinder engine, you have Lambda 1, 2, 3, and 4 set up, and you have a wideband per cylinder, let's say on the header of a naturally aspirated 4-cylinder engine. In the closed loop, it would allow the closed loop to make adjustments on the average of all the cylinders. That would be the best way to handle that if you're in that situation with having multiple widebands. If you have, let's say, a banked engine, you have 2 Lambda sensors, you can set it on Lambda average. It'll go in and average both of those sensors together in terms of the reading for the closed loop control. It really is going to be depending on how you want to handle things. So if you have a single wideband, you typically want to leave it on Lambda average. You could also choose that specific wideband that you wired into the link. In my case, that would be Lambda 1. I'm going to leave it on Lambda average because that works. It's just going to average this wideband, which is going to be the actual reading. There's not more than one wideband. So I'll leave it on Lambda average. Now, the startup timer lockout. This is important to pay attention to. This is going to be how long after the engine cranks, fires, and runs until the closed loop's allowed to turn on and start to make adjustments. Now this value here, it's a time, 5 seconds is what they default. It really depends on what type of wideband you're working with. If, for example, I'm working with my AEM X series wideband gauge, every time I turn the key off, I turn the key on, I crank over the engine, that wideband gauge resets itself. It has to allow the heater circuit about 30 seconds before the wideband will actually show a valid reading. We don't want the closed loop control chasing an invalid Lambda reading, air fuel reading. That'll make it go all haywire and it could lean out. You could have stalling problems. It could go extremely rich and foul, spark plugs. What we want to do here, if we're running an external wideband gauge analog style and we're wiring it in, I would recommend to set up your startup timer lockout to 30 seconds. So every time you shut off the engine and then you turn it back on again, your wideband's going to have to go through that heater circuit warm up.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.